Today we will discuss about the theory of interference fringes with white light. In the last class we have discussed how the interference fringes are produced on a screen with a monochromatic source of light. Today we will discuss what will happen when a white light is being used. So we know that the white light or the visible spectrum varying from 400 to 700 nanometer. So when the slits are illuminated with white light, we will obtain bright point or white point at the center. White means we know that the white light or visible light is colored, that is it varying from 400 nanometer wavelength, that is for blue color to red color. That is approximately about 700 nanometer. So the visible light is a combination of violet to red color. So when we are using this white light as the source of light here for producing interference, we will get white light at the central point on the screen, which means all the lights or the colored lights or all the wavelengths are interfering constructively at the central point, because the path difference is 0 at this point, or they are interfering constructively. For example, I can show you that figure again here for your easiness. That is the previous figure. Yes, so in this figure the central point is O. This is the previous figure where we have used the monochromatic source of light. In here the S is the source, and it is made we have made two slits A and B, and this source of light is placed behind these slits. So the lights are passing through these slits, so that we will get two monochromatic sources A and B when the lights are passing through these slits A and B, and the fringe patterns are observed on this screen. Okay, so C is the central point. So what we are doing is we are using a white light instead of a monochromatic source here. So the white lights are colored. White light is colored. It's varying from blue to red. So all the lights reaching here, that is the point here, is interfere constructively because it travels equal distance to here from A to C and B to C. So we will get a white fringe at the central point, and on both sides of this point, towards this point and towards this side, we will get colored fringes, because when these lights are moving to these sides, they will have a path difference. That is, when light travels from A to this point and B to this point, they travel unequal distance. That means they have some path difference between their path. You can see from this here, if we draw a perpendicular from A to this line BP, this much distance will be the otherness. These things we have already discussed in the last class. So on both sides of the central point, towards this side and towards this sides, the lights coming from both A and B will have a path difference, so that we will get colored fringes on both sides of this screen. So we can see how these fringes are or colored fringes are produced. So let's move back to this previous page. So what happens? So when remember the figure, and at the point P, that is a distance, that is a point which is at a distance y above the central point. The path difference is y small d by capital D. This we have already derived. So imagine if this path difference is 2 into 10 to the power minus centimeter, or 0.2 or 20 microcentimeter, which means this is corresponding to lambda violet by 2. That means if you are calculating the path difference of the two light waves interfering at a point P, which is at a distance y from the central point O, the result is this value is nothing but the half of this value. That means half of the blue wavelength, or violet wavelength. That means the complete destructive interference will occur only for violet. That is, this is the condition for destructive interference. That is, y small d by capital D is nothing but which is equal to lambda by 2, which is nothing but the condition for destructive interference. But this wavelength is corresponding to violet color. So that means the violet color interfere destructively at a point which is at a distance of which having a path difference of 2 into 10 to the power minus 5 centimeter, and which is at a distance y from the central point O. So we will get fringes which is devoid of violet color there at this point. The partial destructive interference will occur for other wavelengths. For other wavelengths, partial destructive interference will occur means the path difference need not be exactly this lambda by 2 value at this point. So but nearly equal to the lambda by 2 value. So a partial destructive interference can be occur for other colors. Consequently, we will have a fringe devoid of violet color and will appear reddish. So what will happen? So at this point on the screen, we will get the fringe which is devoid of violet color, but so that it will become reddish in color. If at some other point, if we imagine some other points on the screen which is at another distance from the central point O, then if you are measuring the fringe path difference of the light waves which are interfering at these points as 3.5 into 10 to the power minus 5 centimeter. So this is nothing but lambda red by 2. You can see that this is the value of wavelength of red light. So 3.5 into 10 to the power minus 5 centimeter means this is half of the wavelength of red light. So we are getting the path difference as wavelength of red light divided by 2. Then at this point, destructive interference occurs for red, and the fringe at this point will appear in violet color. So the red light will disappear. So the condition here is the destructive interference for red color. So red color will be devoid at this fringe, and it will be appear violet in color. So this is what happening when we are using a white light to produce interference fringes. This, following the white central fringe, we will have colored fringe from red which gradually change to violet. So what we are obtaining on the screen is at the central point, that is at the point O, which is at equal distance from the two slits, we will get white light because all the colored light will be interfering constructively here. So we will get white light there, and on the above side and the bottom side we will get colored fringes which varying from red to violet according to the conditions of this path difference. If the path difference is appearing as lambda violet by 2, it will be reddish in color. If it is lambda red by 2, the fringe will be violet in color, and if it is lambda green by 2, then that fringe will be devoid of green color. Or we can discuss it in terms of the bright fringes terms also, or destructive constructive interference fringes also. If the path difference is we are obtaining is obtaining as a the condition for constructive interference is 2n plus 1 lambda by 2. Okay, so we can use that, remember that condition, and we can discuss it in terms of that constructive interference also. So what we are obtaining, that is the path difference is satisfying the constructive interference of a particular color, then that color only will appear on the screen. So we will get colored fringes on both sides of the central fringe. Okay, as for at faraway points from the colored fringes, it disappears because there will be so many wavelengths in visible region which interfere constructively, resulting in uniform white illumination. For example, at any point where path difference is 30 into 10 to the power minus 5 centimeter, which is equal to n lambda, the wavelengths corresponding to lambda is 30 into 10 to the power minus 5 and will constructively interfere here. So we have that means at very far away point from the central points, the fringes will fade away because there can be the light wave from the visible region can be uniform or constructively interfere there. It is shown here with an example. If we are getting a path difference 30 into 10 to the power minus 5 centimeter, which corresponds to n lambda, from this point we can calculate the lambda corresponding to this path difference, which satisfying the condition for constructive interference. Sorry, the constructive interference condition is n lambda. So they will constructively interfere there, so will not get no color there. Okay, so we have shown here 7.5 into these wavelengths are correspond. So the constructive interference, according to this constructive interference condition, these wavelengths are 7.5 into 10 to the power minus 5 centimeter from this equation when n is equal to 4, which is nothing but the wavelength of red light, and for n is equal to 5 this value is merging to wavelength of yellow light, and for n is equal to 6 this value is wavelength of green light, etc. etc. So when this wavelengths are when this path difference is 30 into 10 to the power minus 5 centimeter, that is 2n plus 1 lambda by 2, or lambda is from this expression, or delta is this value, and which is equal to this condition. From this we can calculate the lambda. The wavelengths corresponding to this value is then will be that of orange when we are putting the value n is equal to 4. N is equal to 4, that is about 6.67 into 10 to the power minus 5 centimeter, and for n is equal to 5 this value will be that of wavelength of yellow, that is 5.5 into 10 to the power minus 5 centimeter. This will interfere destructively. So the color of such light seen by unaided eyes appear to be white there. So that color will disappear from the fringes there. So that's what happening. So in brief, we can say that when we are using white light for producing interference fringes, we will obtain centrally white fringe or white fringe at the center and colored fringe on the both sides of the central point. This colored fringe will appear on both sides according to the condition of path difference. That is, the lights from the two slits produced from this white light source is being interfering on the screen, and whether the path difference between these two light source to these slits is satisfying the condition for constructive interference or destructive interference, the color will vary accordingly. If we are measuring the path difference between this wavelength and we are checking whether it is wavelength is satisfying the condition for constructive interference or destructive interference, we can see whether that color is missing from that point or it is constructively interfered there. According to that, we will get colored fringes on both sides of the central point. So this is about interference